McMurdo Station, Antarctica, January 2024. 1,000 people live on a frozen ocean at the bottom of the world. They have flush toilets, they throw away trash, they shower, cook, and work in labs. And every single output, every wrapper, every drop of sewage, every used battery must eventually travel 8,000 miles back to civilization. Because in Antarctica, there is no away. The Madrid Protocol made that illegal in 1991. Burn your trash. You contaminate the air samples scientists use to study the ancient atmosphere. Bury it. Chemicals leach into ice cores. Dumping sewage into the ocean introduces invasive microbes to an ecosystem that has no immune defense against them. So, engineers built systems to combat the cold. Systems that keep water liquid when the air wants to turn it solid, bacteria alive when the exterior temperature is negative 40 degrees Celsius, and pipes from bursting when a blockage turns flow into ice. This is what it takes to make waste disappear in a place where nothing actually can.
All right, so went on a little hike on the road away from McMurdo Station.
Antarctica's air sits at negative 60 Celsius at the South Pole, negative 40 at McMurdo Station on the coast. Water freezes at 0. That 60-degree gap is not background scenery. It is an active, continuous threat to every pipe, valve, pump, and tank carrying liquid. The Madrid Protocol, the 1991 amendment to the Antarctic Treaty System, mandates waste removal, not disposal, which means the infrastructure must stay functional year-round. But the cold fights every component at the molecular level. When water freezes, it expands. A frozen pipe doesn't just clog, it splits. Raw sewage is leaking into a building where you cannot open the windows because the exterior will kill you. Contamination is not just an environmental problem. Scientists come to Antarctica to study trace elements in air and ice, historical carbon dioxide levels, cosmic dust, and ancient climate patterns locked in glacier cores. Burning trash creates smoke that ruins those samples. Buried waste leaches chemicals into the ice. Human sewage introduces microbes and seeds not native to the continent, potential invasive species that could destabilize seal and penguin populations. Antarctica is not just an ecosystem, it is a scientific control group. Contamination is sabotage, so the law requires everything to leave. But keeping systems operational long enough to move that waste requires defending every meter of plumbing against an environment that attacks it constantly.
As we come around the corner, we see building 199, which is the wastewater treatment plant.
At McMurdo Station, pipes do not run underground. The ground is permafrost, rock hard, frozen year-round. Digging is not an option. Instead, the station uses utilidors, insulated, heated tunnels that carry water lines, sewer lines, power cables, and fiber optic communications between buildings. Some utilidors are large enough for a person to crawl through. Others are narrow boxes mounted on stilts above the volcanic rock. Inside, every pipe is wrapped in electric heat trace cable, a heating wire taped along the length, then covered with aluminum foil to spread the warmth, then encased in 2 to 4 inches of fiberglass insulation, then jacketed in white PVC to protect it from moisture and damage. If the power fails, the heat trace stops. Water in the pipe will freeze within minutes to hours, depending on the diameter. Critical lines have double heat trace circuits for redundancy, but redundancy only buys time. Modern heat trace cables are self-regulating. The conductive core increases heat output as the pipe gets colder and decreases it as the pipe warms up. This saves energy and prevents overheated plastic pipes. Water also stays liquid because it never stops moving. Potable water systems are designed as loops. Pumps run 24 hours a day, circulating water through the network. Moving water is harder to freeze. The flow disrupts ice crystal nucleation. If a pump fails, an alarm sounds immediately in the operations center. Maintenance crews have a very short window to restart the flow before the pipe begins to freeze. The station also uses glycol loops for heat transfer. Propylene glycol mixed with water, non-toxic antifreeze, circulates through heating systems for buildings and cooling systems for power plant generators. The waste heat from generators is captured by glycol loops and used to melt snow for water or heat the dormitories. This is cogeneration, using waste energy from one system to power another. The system is not passive. It requires constant energy input and human vigilance. One failure cascades into the next. McMurdo's wastewater treatment plant replaced an older system, a macerator, essentially a giant blender that chopped raw sewage and pumped it directly into McMurdo Sound. That created a localized pollution zone on the seafloor. The new plant uses aerobic bacteria to digest the waste, but bacteria are living organisms. They need warmth to survive and reproduce. While the exterior temperature hovers at -40°C, the plant maintains an internal heated environment, a microclimate for microbes. The process starts with maceration and screening. Large solids and items that should not be there, wipes, plastics, anything non-biodegradable, are filtered out. Then the waste enters the biological digestion tanks. Aerobic bacteria break down organic matter over several hours. The tanks are insulated and heated. If the heating system fails, the bacteria die. If the bacteria die, the plant stops processing waste. The station drowns in sewage. After digestion, the effluent is sterilized with high-intensity ultraviolet light instead of chlorine, which would harm the ocean ecosystem. Then it is discharged into McMurdo Sound. The solid byproduct, sludge, is removed and sent through a belt press to squeeze out as much water as possible. Drying reduces weight and volume. The dried sludge is packed into containers and stored in a freezing warehouse until the annual resupply ship arrives. That sludge will travel 8,000 miles to California for final disposal. The waste system has its own life support system. Humans depend on the plant depends on the bacteria. The bacteria depend on heating. Heating depends on power. Power depends on fuel. One break in the chain and the entire station is at risk. A toilet backs up in Building 155. It is a Saturday. The blockage stops water flow in a section of the sewer line. The pipe is insulated. It is heat traced. But heat trace is designed to maintain temperature in flowing water, not to thaw ice once it forms. Stationary water begins to freeze despite the heat. Ice crystals nucleate inside the pipe. Within hours, the ice plug expands. Steel pipe is strong, but ice is stronger. The pipe splits along a seam. Raw sewage begins to leak. The building's ventilation system is designed to keep warm air in and cold air out. It is not designed to vent sewer gas. The leak is discovered when someone smells it. The maintenance crew responds immediately. They isolate the section by closing valves upstream and downstream. They drain what they can. Then they bring in Herman Nelson heaters, forced air propane heaters the size of suitcases, and aim them at the pipe. The goal is to thaw the ice plug without causing further damage, but the ambient temperature in the utility space is -40°C. Applying heat in that environment is slow. If the pipe is already split, thawing just makes the leak worse. In that case, the crew has to cut out the damaged section and replace it. This means working in the cold with bare hands for short intervals, then retreating to warm them, then going back. Frostbite risk is real. The work is messy. Frozen sewage does not smell. Cold suppresses odor molecules, but once it thaws, the smell returns instantly, preserved perfectly. Pump failure alarms trigger instant response because the window between flow stoppage and freeze is minutes, not hours. Every plumber at McMurdo knows that a code brown, station slang for a sewage emergency, is not just a maintenance problem. It is a survival problem. There are no hardware stores. There is no calling a contractor. You fix it with what you have, or the building becomes uninhabitable. McMurdo Station achieves a 60 to 70% recycling rate. That is double the United States national average, which hovers around 30%. The difference is not technology. It is labor. Residents sort their own trash at the source into 8 or more categories: aluminum cans, white paper, mixed paper, flattened cardboard, glass, food waste, biological waste, construction debris. The sorting system is called the skua, named after the scavenging Antarctic bird. Then the bags go to the waste barn, where workers called wasties inspect every single one. If they find a sorting error, a battery in the paper bin, a food wrapper in the aluminum pile, they dig through the entire bag to find and correct it. The goal is volume reduction. Shipping space to and from Antarctica is the most valuable currency on the continent. Cardboard is baled with a hydraulic press. Cans are crushed flat. Glass is packed tight to eliminate air gaps. Everything is weighed and logged. The waste barn operates in an unheated building. Workers wear insulated gloves, but sorting requires dexterity. Sometimes they work with bare hands for short periods. The biggest fear is lithium-ion batteries. A crushed lithium-ion cell can ignite. Fire is the #1 danger in Antarctica. The air is extremely dry. Antarctica receives minimal precipitation and qualifies as a desert. Water is frozen and difficult to access quickly. Buildings are insulated and sealed against the cold, which means they trap heat and smoke. A fire in the waste barn could spread to fuel storage or the main station, so battery buckets are placed everywhere. In dormitories, labs, kitchens, workshops. Signs remind people to check their pockets and bags. Wasties are trained to be paranoid. They look for the telltale shape of a phone, the weight of a power tool battery, the faint outline of a charging cable. They shake bags to listen for the rattle of AA or AAA cells. They examine every suspicious lump. Checking for batteries is the most careful part of the job. It is also manual. There are no X-ray scanners or metal detectors in the waste barn. Just human eyes, human hands, and the knowledge that a single mistake could burn down the station. To understand how far the system has come, you need to understand what Antarctica was before 1991. In the 1950s through the 1980s, the continent was treated as a frontier dump. Trash was piled on the sea ice or in designated areas and set on fire. Black smoke from burning plastics and fuel coated the glaciers with soot. Old vehicles, trucks, bulldozers, tractors were towed out onto the seasonal sea ice. When summer came and the ice broke up, the vehicles sank to the bottom of the Ross Sea. Barrels of waste, broken equipment, and construction debris went the same way. Out of sight, out of mind. Raw sewage flowed directly into the ocean with no treatment. The macerator at McMurdo chopped it into smaller pieces, but it was still untreated human waste entering the marine ecosystem. Nobody thought much about it. Antarctica was remote, cold, and enormous. The assumption was that the environment could absorb anything humans left behind. The Madrid Protocol changed that, signed in 1991 and entering into force in 1998. It designated Antarctica as a natural reserve devoted to peace and science. Annex 3 of the protocol specifically addressed waste disposal and mandated removal. Everything had to leave. In the 1990s and 2000s, cleanup crews spent years recovering the mess. Divers went into McMurdo Sound to pull up sunken machinery. Surface teams dismantled old dump sites and packed the debris into containers for retrograde shipping. It was expensive, dangerous work. Some of the waste had been there for decades, rusted and frozen into the ice. Today, the standard is absolute. If a bulldozer breaks beyond repair, it is disassembled, drained of all fluids, cleaned, and shipped back to the United States for scrap metal recycling. Nothing is left behind. The protocol forced a complete inversion of how waste is handled. Antarctica went from the least regulated place on Earth to the most regulated. Amundsen Scott, South Pole Station sits at 90 degrees south, 9,300 feet above sea level, on top of a glacier 2 miles thick. The temperature is a steady negative 60 degrees Celsius in winter. There is no ocean to discharge wastewater into. There is no liquid water at all. To have sewage, you first need water. Engineers produce it using rod wells, Rodriguez wells, named after the engineer who designed them. The process involves drilling a hole deep into the ice, then circulating hot water down into it. The hot water melts the surrounding ice, creating a bulb-shaped cavity several hundred feet below the surface. The meltwater is pumped up for station use. As the bulb grows too large or the roof threatens to collapse, the well is abandoned and a new one is drilled nearby. Melting ice requires massive amounts of jet fuel to power the heaters. Every flush of a toilet at the South Pole represents a significant fuel cost. People at the pole eat nearly 4,000 to 5,000 calories a day to maintain body heat in the extreme cold. High-calorie input means high waste output. The sewage systems are designed for heavy load compared to a standard office building. Logistics experts estimate that when you factor in the fuel to melt the water, the heat to keep the room warm, the power to pump the waste, and the energy to inject it back into the ice, a single flush costs $15 to $30 in logistical energy. Sewage disposal uses the same principle in reverse. Macerated sewage ground up but not biologically treated, and graywater from sinks and showers are pumped into abandoned rod wells or dedicated sewage shafts 200 to 300 feet deep. The waste freezes instantly upon contact with the surrounding ice. It becomes encapsulated in the glacier. The South Pole ice sheet flows toward the coast at roughly 30 feet per year. The sewage moves with it, buried and frozen. It will eventually reach the edge of the continent and calve off as an iceberg. That will take approximately 20,000 to 50,000 years. By then, biological breakdown and dilution in the ocean will have rendered it harmless. In the ice tunnels beneath the station, the frozen sewage outfall creates a stalagmite of waste under the ice. Because the ambient temperature in the tunnels is negative 50 degrees Celsius, the sewage does not smell. Cold suppresses odor molecules completely. But if you heat it up, by drilling into it accidentally or bringing it to the surface, the smell returns instantly, preserved perfectly across decades. The Madrid Protocol allows this method at the South Pole because there is no feasible alternative. You cannot store liquid sewage for a year. It would freeze into an unmanageable solid mass. You cannot ship it out. The LC-130 Hercules cargo planes that supply the pole cannot carry that much liquid weight. Deep ice injection is the only solution. When scientists leave McMurdo or the South Pole to work in remote field camps, on glaciers, in mountain valleys, in the dry valleys, they leave the plumbing behind. Waste management becomes manual logistics. Every person carries a dedicated pee bottle. It is usually a wide-mouth Nalgene, clearly marked with tape so no one drinks from it by mistake. You urinate inside your tent or sleeping bag at night when it is too cold or dangerous to go outside. In the morning, you empty the bottle into a central 55-gallon drum. The drum is eventually strapped to a pallet and flown back to McMurdo for treatment. The rule is absolute. You do not urinate on the snow, ever. Urine contains sodium, nitrogen, and other compounds that alter the chemical composition of the site. Scientists studying pristine ice or ancient climate records need the snow to be uncontaminated. A pee spot ruins the data. Solid waste is handled with bucket toilets or wag bags. A bucket toilet is a 5-gallon plastic bucket lined with a heavy-duty trash bag, sometimes with a toilet seat snapped on top. Some camps call it a rocket or a groover, depending on the style. You do your business in the bag, seal it, and store it in a separate container. Wag bags, waste alleviation, and gelling bags are more advanced. They contain a powder that absorbs liquid and turns the waste into a stable gel. You use the bag, seal it, and pack it in your sled. Liquids and solids must be kept separate. Urine is heavy and voluminous. Mixing it with solids makes the waste heavier, smellier, and harder to transport. Solids can be dried or frozen to reduce weight. Liquids must be contained in drums. Graywater, water from dishwashing or brushing teeth, has its own rules. In some camps, you can pour it into a designated sump, a pit dug in the snow, as long as you strain out solid food particles first. The location is GPS marked so future scientists know that patch of snow is compromised. In the dry valleys, which are specially protected zones with unique ecosystems and ancient geology, the rules are stricter. 100% removal. You spit toothpaste into a bottle. You pour dishwater into a drum. You bring everything back. The field strips away the illusion of modern waste management. There is no flush. There is no trash can that someone else empties. You carry your own waste, sometimes for days or weeks, until a helicopter comes to retrieve it. Once a year, usually in January or February during the Antarctic summer, a cargo ship docks at McMurdo Station's ice pier. The ice pier is a floating dock made entirely of frozen seawater, reinforced with steel cables and gravel. It can hold the weight of a full cargo vessel. The ship is often the Ocean Giant or a similar heavy lift vessel. It arrives loaded with supplies for the next year: food, trucks, scientific equipment, building materials, and fuel. Then it loads the retrograde cargo, the waste. The green wave is the colloquial term for the shipping containers full of waste leaving Antarctica. Refrigerated containers hold frozen urine barrels and biological waste. If they thawed during the voyage through the tropics, they would leak and contaminate the ship. Hazmat-certified containers hold batteries, laboratory chemicals, radioactive isotopes from scientific instruments, and other regulated materials. These are packed by certified specialists according to international shipping law. Recycling containers hold baled cardboard, crushed cans, and sorted glass. General waste containers hold whatever cannot be recycled or treated on site. The ship travels 8,500 nautical miles to Port Hueneme, California, or sometimes to ports in Washington state. The voyage takes 2 to 3 weeks. Once in the United States, the containers are offloaded and sorted again. Recyclables enter the domestic market. Hazardous waste goes to specialized disposal facilities. General trash goes to landfills. The irony is that waste is handled with higher standards in Antarctica than after it reaches the United States. McMurdo's 60 to 70% diversion rate is higher than most American cities achieve. The manual sorting, the inspection, the careful separation, all of that effort is required by the Madrid Protocol. But once the waste crosses back into U.S. jurisdiction, it is subject only to standard municipal and federal regulations, which are less strict. A candy wrapper's full life cycle illustrates the system. It arrives on a C-17 Globemaster cargo plane from Christchurch, New Zealand. A scientist eats the candy bar in a lab. The wrapper goes into the mixed paper bin. A wastie collects the bin and brings it to the waste barn, where the wrapper is inspected and compressed into a bale with other paper products. The bale sits in a freezing container for 9 months, waiting for summer and the supply ship. It is loaded onto the Ocean Giant. It travels through the Southern Ocean, past the Drake Passage, up the coast of South America, through the Panama Canal and north to California. It is offloaded, trucked to a recycling facility in Tacoma, Washington, and processed. The wrapper traveled 16,000 miles round trip. It required fuel, labor, ships, planes, forklifts, inspections, documentation, and international coordination, all to remove a single piece of trash from a continent where it was never supposed to stay. Antarctica forces visibility. No sewer disappears underground. There is no landfill over the horizon. There is no municipal truck that takes the trash away while you sleep. Every output becomes an input to a reverse logistics chain that spans hemispheres. The cold attacks the infrastructure constantly, turning stagnant water into pipe-splitting ice, threatening bacteria with extinction, and making every flush a $15 fuel calculation. The law requires removal because contamination is not just environmental harm, it is scientific interference, data corruption, the introduction of invasive biology into an ecosystem with no defenses. So engineers built closed-loop systems that fight the freeze with heat trace in circulation, that keep bacteria alive in hostile climates, that turn glaciers into geological disposal sites, and that force humans in field camps to carry their own waste in bottles and bags. The wasties inspect every bag. The ship makes 1 trip a year. The candy wrapper travels 8,000 miles. The continent tolerates human presence only under one condition. You erase your footprint. You bring nothing that stays. You take everything that leaves. In Antarctica, waste management is not a service. It is a demand made by an environment that rejects you at every level. And the price of meeting that demand is constant vigilance, enormous energy expenditure, and a logistics chain that spans the globe just to make a candy wrapper disappear.